In this screencast, we'll do an example of hypothesis testing for one population proportion. So here's our research question. A researcher wants to know if the proportion of U.S. high school students who are in private schools is less than 0.10, 10%. And we'll use our PISA data to answer that. So first we look at the raw data. The sample size for PISA is 990, and of these, 88 students were in private schools, so we have sample size n equals 990, and sample proportion, p hat, of 88 divided by 990, or 0.087. So this is the data we're working with. We see that 0.087 is less than 0.10, but the question is it so much less than we believe that 0.10 is not the true population proportion? In other words, is this 0.087, is that statistically significantly lower than 0.10? So to develop some intuition, we're going to run a simulation using our app. So remember what this does. What the simulation does is pretend that the proportion really is 0.10 and send 1,000 different virtual researchers into the community to sample 990 students. So we'll change the population proportion to 0.10. Oops. 1. Sample size is 990. And remember that what we got was 0.087 as our sample proportion. And in this example, we find that there's the 10.8% of our sample proportions were less than 0.087. In other words, we sent 1,000 researchers into our virtual community, into our simulation, where the population proportion really was 0.10, and each of our 1,000 people took a sample size of 990, and this is a histogram of the results. And 10.8% of those sample proportions were less than 0.087. So it's not all that surprising. And let's run the simulation one more time just by re-entering the 0.087, and now we get 10.1%. So if the actual proportion were 0.10, the portion the research we're comparing to, would it be surprising? No, not that surprising. Now we carry out a formal hypothesis test. So this was just to give us some intuition, and it says, okay, it wouldn't be all that unusual to find a sample proportion this low if the population proportion were 0.10. So state the null and alternative hypothesis. Null hypothesis, p equals 0.10, alternative p less than 0.10. So now we use our inference procedure tool. Sample size is 990. Sample proportion was 0.087. A hypothesized proportion was 0.10. And we get a z-statistic of negative 1.36, and we get a p-value, remember our alternative is less than, so we get a p-value of 0.086. So p-value is 0.086, so we do not reject the null hypothesis because our cutoff is 0.05. We only consider something statistically significant if the p-value is less than 0.05. So the original research question, we do not have evidence. We did not reject this. We couldn't rule it out. A sample proportion was less than that, but it wasn't so far less as to be all that surprising. So we couldn't rule this out. We do not reject the null hypothesis, which means we do not have evidence, or we do not have sufficient evidence, that the proportion is less than 0.10. And why did the p-value lead to that conclusion? Well, if the true population proportion were 0.10, there would have been an 8.6% chance of getting a sample proportion as low or lower as the one we got. And this would not be that unusual. By the way, in this example, the p-value of 0.086 was very close to the sample proportion of 0.087, but this is only a coincidence, so don't think that those two things are the same or close together usually. Okay, so this is step 3 here. This is the best way to do hypothesis testing using our tools. This is how you'll do it normally. This simulation is just to get some intuition, to see what's going on. And notice, by the way, that the simulation didn't give us that same 0.086 because it was just a simulation and there's variation. So remember what's going on behind the scenes. The Excel sheet is doing some calculations for you, but it's not magic. If the population proportion were 0.0, then by our sampling distribution theory, the sample proportions would have mean 0.10, standard deviation, square root of 0.10, 1 minus 0.10 over 990, or 0.0095. And our sample proportion would then have a z-score of negative 1.36345. To get our p-value, we use norm S dist, and there's our p-value of 0.086. By the way, if you re-enter some of these numbers as I've written them, you might get slightly different results, because what I wrote down here for the 0.0095 was, I did some rounding, but I kept everything in my calculator, so these are the actual numbers, which is why it agrees with Excel. But if you put in 0.0095 here with the rounded number, you might get something slightly different. Don't worry about that. So when you're actually doing a hypothesis test, it's this step 3 is what you'll do. But step 2 will give you some intuition and let you see what's going on. It shows you what happens if the proportion were 0.10 and you went out and did a bunch of samples, took multiple samples of size, well in this case 990. So hopefully this helps a little bit with hypothesis testing.